My teaching experience has led me to believe that intermediate students are often disengaged in curriculum areas and subjects that they cannot find purpose for, specifically mathematics. I have taught grades 6, 7, and 8 and experienced high levels of disengagement from a large portion of my students in all three grade levels. According to a study by Bodovsky and Farkas in Mathematics Growth in Elementary School, The Roles of Beginning Knowledge, Student Engagement, and Instruction, there is a reciprocal relationship between student engagement and academic success. The study found that students achieving higher grades demonstrate higher engagement, therefore creating a positive cycle that continues throughout their elementary education. The focus must then turn to increasing the engagement levels of all students, not only high-achieving students, to encourage the development of this reciprocal relationship. The following two-part research question is stemmed from my research problem statement. Part 1 will be the main focus of this action research study, and Part 2 would be completed following the initial completion of Part 1. Part 1. What strategies could be used to increase student engagement in mathematics in the intermediate grades? Part 2. Is mathematics engagement demonstrated by intermediate students a reflection on their experiences in mathematics in junior and primary grades? If so, is there a way to adjust the mathematics program to increase long-term engagement? Part 2 would have to be completed over a much longer time period. For the time being, research through journal analysis will be used to answer this portion of the question, and action research will be performed to answer Part 1 of the research question. The following definitions are being used to demonstrate the use of the word in the context of this action research problem. Strategies: tangible and proactive plans that could be put into action within the classroom to ensure long-term student success. Student engagement: attention, interest, and curiosity shown for the subject matter. Mathematics engagement: attention, interest, and curiosity shown for mathematics. Experiences: the events or occurrences that have occurred in previous grades that have had effect on a student's relationship with a particular subject. Mathematics program: the structure and variety of learning opportunities provided in a mathematics classroom. Long-term engagement: continued and increasing attention, interest, and curiosity for the subject matter spanning year after year. The following 3 slides will introduce you to the literature that was used during the development of this action research study. The article titled Mathematics Growth in Early Elementary School, The Roles of Beginning Knowledge, Student Engagement, and Instruction provided evidence that directly correlates with my second research question: how do teaching strategies experienced in the junior grades affect learning in the intermediate grades? The article's focus is mainly on student experience between kindergarten and grade 3. However, the research showed that lower-level learners and students with prior knowledge in kindergarten demonstrated less growth in academic success by the time they reached the 3rd grade, therefore demonstrating that academic experience in primary grades likely affects academic experience in junior and potentially intermediate grades. Much of the evidence was rooted in the amount of time allotted to mathematics instruction in the first 4 years of school. In my own teaching experience, I have also noticed the frequency to which teachers choose to take instructional time away from math in favor of other subjects. Thus, the article was able to demonstrate both mathematics engagement and success are affected by style and consistency of instruction. Although this study was focused on primary, I am using it to demonstrate that style of instruction and instructional strategies can have effect on student engagement and therefore support the topic of this research study. The book Hacking Project-Based Learning: 10 Easy Steps to PBL and Inquiry in the Classroom provides evidence of inquiry, a successful engagement tool for students, as well as introduces educators to strategies proven to assist with implementation. Inquiry and project-based learning are designed for students to gain understanding of real-life application of the subjects being taught. These instructional strategies improve critical thinking skills and encourage students to act independently by being given responsibility for their own learning. My teaching experience has taught me that students are far more engaged when they believe that their learning has purpose. Project-based learning provides them with the independence that they often require to be invested in and uncover said purpose. Although the book is not specific to the subjects I am inquiring about, it is supportive of my research because it responds to my questions about strategies and instructional tools to use for increasing student engagement. One of the book steps is develop a space that promotes risk-taking. The connection with my action research can be understood by the quote provided at the beginning of the chapter: "Fear is the enemy of curiosity." The strategy involves encouraging mistakes and high-reward risks amongst your students. Often it seems as though disengagement in math is a result of being afraid of not understanding or of making mistakes. If this strategy is implemented correctly, students will be more comfortable jumping into difficult tasks and therefore demonstrate more engagement in their work. The book is designed to make implementation easier for teachers and therefore increase the success of the projects and learning experiences for the students. The research synopsis breaks down a variety of areas that have affected student success during the recent period of mathematics reform. Mathematics reform is the approach to mathematics and the changes in curriculum that have occurred in many parts of North America since the late 20th century. The research is inclusive of a variety of subtopics. However, the information about adolescent mathematics learners, differentiated instruction, and differentiation based on student interests are of most importance to my action research. The research suggests that it is of the utmost importance that teachers are aware of where their students fall in the learning continuum when they are planning their classes, and that it is okay for different students to be working on different tasks within the same class period. The evidence supporting this information suggests that providing tasks and activities appropriate to the level of the learner, as well as the interests of the learner, increase engagement and success in mathematics. Evidence has also shown that adolescent students learn mathematics best in environments which allow for physical activity, social interaction, technological investigations, choice, variety, and meaningful input. This information directly correlates with my research questions about strategies for increasing student success and engagement in mathematics. It is integral that teachers get to know their students individually as to provide opportunities for them to participate in kinesthetic and personalized activities tailored to their learning levels, interests, and needs. The following slides demonstrate the plan that will be used to carry out the action research. This will include the strategies, people, and setting involved. Data sources. Focused teacher observations will be performed to ensure groups under study within the same grade level are experiencing different styles of instruction for the same strand of mathematics. The purpose of this observation is to ensure consistency of results. This source will be used to assess different levels of engagement depending on style of instruction. Conversations and interviews with students achieving a variety of academic grades will occur consistently throughout the unit under observation about their level of engagement with the subject. The purpose of this observation is to gather qualitative data on the relationship between the style of instruction, level of engagement, and academic achievement. Diagnostic and summative standardized testing will be completed by all students under observation. All students will complete a standardized test before and after the unit under study has been taught. This will provide a benchmark for ensuring students at a variety of academic levels are being interviewed for qualitative data. Furthermore, it will demonstrate whether different teaching strategies affect academic success and/or student engagement. As pointed out by my reviewer, using standardized testing may not be the most effective assessment strategy for all students. However, alongside observation and conversation, it should allow for students to demonstrate understanding using a variety of strategies and therefore provide at least one strategy to accommodate each type of learner for data collection. Triangulation, validity, and reliability ensure the results of action research are accountable. Triangulation refers to the use of two or more sources or research methods to collect data and ensure validity. Validity means the credibility or believability of results, and reliability means the results of the action research demonstrate consistency over time. Qualitative and quantitative data will be used to ensure triangulation for this action research. The use of observation will ensure that the methods of instruction and engagement strategies are varied between classes. Conversation with the students will provide specific and first-hand understanding of which strategies provide the most clarity and encourage the highest levels of participation. Conversations will be both one-on-one and in small group to ensure personal statements are gathered, but that the students also have opportunity to converse with each other and therefore elaborate further on the data being collected, as some students find it more difficult to communicate without prompting. The collective results between the observations and conversations will ensure the validity of the final results. If the information between the observations and conversations align, then the believability of the study will be increased. The use of diagnostic and summative standardized testing will provide concrete demonstrations of the differences in academic success depending on the style of instruction and classroom strategies used. This quantitative data will focus on the percentage difference per student between the initial and final test completed rather than the actual scores themselves. The goal would be to complete this exact same study within a variety of schools in varying geographic areas to ensure reliability of results. However, to ensure reliability in each individual study, it would be necessary for the research to be done in a school with a rotary schedule, so the same teacher would be in charge of all instruction and observation and conversation, and could therefore ensure consistency and identical repetition in each stage of the action research. All initial research will be completed within one elementary school by one classroom teacher who instructs on a rotary schedule and therefore has the opportunity to teach mathematics to multiple classes. If possible, the study may be completed simultaneously by classroom teachers in different schools that are in different geographic locations to increase reliability and validity of results. The classroom teacher will be the main researcher. They will be in charge of designing different strategies for teaching math, i.e., one class will experience inquiry-based learning and high-yield mathematics strategies, whereas the other class may experience more individual and independent work. The classroom teacher will be responsible for collecting, recording, and relaying the results of the action research. Students in 2 different intermediate classes will be the main focus for the initial study. The 2 classes will experience different teaching strategies and learning activities. In time, an identical study may be done in the primary and/or junior grades, and then again on the same students when they reach the intermediate grades to provide data for part 2 of the research question. In order to ensure the privacy and confidentiality are maintained for the participants in the study, school and participant names will be released by generic pseudonyms in written data. Only audio recording devices will be used to record groups and one-on-one conversations with students. All students participating in the study will be required to attain the signature of a parent or guardian that allows them to be included in the study. If part 2 of the research question is completed, school boards and general school locations will be included in the long-term study to demonstrate the variety of geographic locations for which the study took place. The following is a timeline of when and how data will be collected. The unit will begin with the completion of a diagnostic test by all students on day 1. Small group conversations involving 2 to 3 students who demonstrated academic levels ranging from 1 to 4 on the diagnostic test will occur 4 times throughout the unit, once after diagnostic, 2 throughout, and once after summative assessment. One-on-one conversations will occur with the same students, but only twice throughout the unit, once after diagnostic and once after summative. All conversations will be between the students and the classroom teacher. Anecdotal teacher notes based on observation and conversation will be completed twice weekly throughout the unit, as well as during group and one-on-one conversation. Written reflection on unit activities will be completed by the students on the second last day of the unit, and finally, a summative test will be completed by all students on the last day of the unit. Designing this action research study would support my knowledge of teaching in a few ways. Understanding student engagement is extremely important to both ensuring student success and implementing efficient classroom management. If students are not engaged, they may be less likely to demonstrate enough interest to understand the material and may be more likely to act out in classroom or disobey rules. This study would allow me to understand the types of teaching strategies that support and do not support the highest levels of student learning. This study has been focused on mathematics because my experience has demonstrated that this is a particular area of concern for many students. However, the results of this study should provide teaching strategies that could be used on a variety of subject areas. I had originally included information about the impact of EQAO scores. However, as pointed out by my reviewer, this study is focused on student success, so I changed that to demonstrate how the results could be applied to increase student engagement in other subjects. The following slides break down the 3 pieces of literature that were referenced throughout the development of this study and summarized earlier in the presentation. The first is Mathematics Growth in Early Elementary School, The Roles of Beginning Knowledge, Student Engagement, and Instruction by Badovsky and Farkas. The second is Hacking Project-Based Learning by Ross Cooper and Aaron Murphy. The third is a research synopsis in Connecting Practice and Research in Mathematics Education, as found on EduGames.